remember Roger Penrose's idea that the human brain uses quantum effects in microtúbulos and that those are the origin of consciousness? Yeah, that sounds pretty crazy. But, well, it seems that he was right, at least about the microtúbulos. What the heck are microtúbulos? Microtúbulos are big molecules, basically. They are essential parts of all cells in the human body and play a big role for signal transport in the human brain. They're polymers that combine two tubes and are made of smaller components called tubulin. So the tubes are made of tubules that are made of tubulin. It's tubes all the way down, people. Roger Penrose now has this idea that consciousness can't be explained by a computable process. So there needs to be an uncomputable element in what the brain does, and that, he says, can only be the collapse of the wave-functioning quantum mechanics. The collapse is when a quantum distribution of possibilities collapses to one actuality. His hypothesis is that this happens in the human brain, and that's what creates conscious thought. Why the collapse of the wave function? Because we know that all the rest is computable, so that's the only place you can hide something non-computable. The problem with this idea, as many physicists have pointed out, is that the human brain is a warm and noisy place, and these are generally not very welcoming to quantum physics. There's a reason that current-day quantum computers are suspended from 3 levels of shock absorbers and cooled to a few millikelvin. It's not just because it looks impressive, though there's that. It's because otherwise the quantum effects just go away too quickly to do any computing with them. For Penrose's idea to make any sense, you'd have to have quantum effects survive in the human brain at least until a neuron has managed to fire. And the human brain is ridiculously slow in its firing. Even the most basic estimates say that it wouldn't work out. Penrose originally didn't say anything about specifically how these quantum effects should come about in the human brain, but he later teamed up with Stuart Hammeroff, a neurobiologist who had this idea that it'd be the microtúbulos. The microtúbulos, Hammeroff convinced Penrose, can basically synchronize due to quantum effects, and that helps the quantum effect survive for long enough to play a role in conscious thought. That still doesn't explain what any of this has to do with consciousness, but at least that'd make it plausible that the collapse of the wave function plays any role in the human brain. I've heard more than one person say, what a pity that Penrose fell for this crazy Hammeroff person. But well, I've met both Penrose and Hammeroff, and they're both crazy, of course, but neither of them is stupid. So what are we to make of this microtubule business? Now comes this new paper from a group that doesn't seem to have anything to do with either Penrose or Hammeroff, and they say that they have clear evidence that these microtubules actually do display real quantum effects. More specifically, it's a process called superradiance. It basically requires the molecules to have quantum links to each other to achieve a larger emission of light. They first built a computer model for how the tubulin molecules combine to microtubules and how they would absorb light. Then they also tested this in the laboratory, and they found good agreement. Both theoretically and experimentally, they say that yes, these tubules can display quantum effects. They didn't actually test it in a cell, just in a solution, but it's at room temperature, and they say the super-radiant effect basically doesn't care about the environmental noise. This is very interesting, just because it's an example for quantum-enhanced effect that seems to be unexpectedly robust. I'd be surprised if not the quantum computing people will try to use it. Another interesting part of the paper is that they say that the quantum effects in these microtubules can do something else, which is that they become much more efficient at absorbing ultraviolet light and redistributing it to lower energies. That is, they basically protect cells from the potential harm of ultraviolet light. In the press release, the researchers say if these quantum effects fail, that might play a role for degenerative brain diseases. I'm somewhat skeptical about this, but then this isn't my research area. What does any of this have to do with consciousness? Nothing really, though last time I looked we did need brain cells for consciousness. There seems to be a big logical gap between there are quantum effects in human brains and quantum effects create consciousness. Though, come to think of it, maybe the time has come for a quantum consciousness startup.